Hello, friends of human spaceflight, and welcome to another week in review as we look into the space industry and notable launch activities from around the world. Coming up, time to top up the International Space Station with supplies from another SpaceX Cargo Dragon mission. We take a look at some interesting science that made the journey. The Psyche mission to a distant potato-shaped asteroid looks to be back on. Did we see a delay here in attempting to launch last year, or is all not as it seems? The answer will very much surprise you. A new European launch provider had a major milestone recently as they continue to edge closer to an inaugural launch. Beam me down, Sky! What's that now? Sending captured solar energy down to Earth from an orbiting spacecraft. How is that even possible? We definitely have to take a look under the hood on this one. Blue Origin tourism and cargo flights may be set to resume after that launch anomaly in 2022. When will they lift off once more? Plenty happening this week. We hope you enjoy this episode, so let's go! On Monday, June 5th, 2023, the 28th Commercial Resupply Service mission was successfully launched from Launch Complex 39A at Kennedy Space Center in Florida at 11:47 a.m. local time, after a 2-day weather delay. The mission, known as Dragon CRS28 is an autonomous cargo capsule carrying some 3,300 kilograms, or 7,200 pounds of cargo destined for the International Space Station. Liftoff was smooth and all systems nominal as Falcon 9 streaked skyward. In no time at all, we saw the main engine cut off and stage separation. As the 5th flight core stage began to set itself up for re-entry, focus switched to the 2nd stage. Of particular interest here, you will note the shortened MVAC engine bell, which helps reduce manufacturing time and overall production cost. Roughly 9 minutes later, the booster used for the launch safely landed on the drone ship named A Short Fall of Gravitas, located in the Atlantic Ocean. The mission encompassed numerous experiments and technology demonstrations spanning a wide range of areas. These included vegetation experiments and a new pair of Arosa rollout solar arrays for the ISS, seen tucked away in the trunk section attached to the capsule as Dragon separated from the 2nd stage on its journey to the ISS. These arrays will be installed in future spacewalks and augment power for a very busy orbital outpost. The CRS28 mission also carried 6 CubeSats. Among them, 5 were of Canadian origin, sponsored by Nanoracks. The 6th and final CubeSat is really interesting. Called Moonlighter and developed by the Aerospace Corporation and a US satellite. Notably, Moonlighter holds the distinction of being the world's first and only hacking sandbox in space. Its primary purpose is to serve as a cybersecurity testbed dedicated to identifying and preventing hacking methods targeted at satellite systems in space. Back to other experiments for a moment. Clingers, which stands for Compliant Low Profile Independent Non-Protruding Genderless Electronics Rendezvous System, utilizes a combination of mechanical docking and rendezvous sensors to enable units to securely join together in space. Seen here in a past test using an airbed with testing in space to incorporate sensors being attached to robotic astrobees and testing in a 3D environment. With its capabilities to potentially be used to remove space debris and assist astronauts with various tasks, Clingers goes beyond that. Its primary objective is to investigate how humanity could construct large structures in orbit, recognizing the necessity for reliable methods to hold individual pieces in position. Space is a remarkable place to conduct so many wide-ranging experiments, such as those found on this mission. Fast forward now, and roughly 18 hours after liftoff, Cargo Dragon docks safely with the International Space Station. It's back and coming to a metallic asteroid near, well, far, far away actually. It's some 450 million kilometers or 280 million miles from Earth. Psyche is on again after it missed 2 launch window opportunities in 2022 due to delays in the development and testing of flight software. This delay sadly also indicated a much deeper systemic issue within the Jet Propulsion Laboratory at the time. With a strained and stressed workforce and suboptimal internal communication practices, delays have now blown out the cost of the Psyche mission. projected at just under $1 billion at the time of its inception in 2015, now it's at an estimated budget more like $1.13 billion as of January 2023. This figure is still yet to be confirmed and is expected to be much higher, mainly because the journey will now take much longer. After some restructuring and leadership reshuffles at JPL, among other changes, the Psyche project is looking green across the board once again, as they count down to an October launch in 2023. Now, here's a twist. If you look back at earlier information on the Psyche mission timeline, say around 2017, the date for the launch was actually what we hear now. Yes, Psyche was actually brought forward to 2022, and at day's end, they just weren't ready to meet an ambitious schedule. So are they behind in the original timeline? It appears not. Asteroid Psyche, located between Mars and Jupiter, is thought to be the exposed core of a planetesimal, or a planet that was forming in the distant past but never came into being. With a diameter of about 225 kilometers or 140 miles, we know it's not a rock or icy body, but a dense metallic structure and a magnet to the scientific community, hoping to be able to study this deep space object. It would be like peering into the heart of our very own planet's core. Then again, it could just be a potato-shaped ancient space blob of unmelted material, but let's hope not, given the cost to develop and send this space probe there. If launched later this year, as originally planned, the space vehicle will arrive at the Spud Rock around 2029, taking 100 days to complete its approach phase, where it will then settle into orbit and study it over some 26 months. On June 2nd, launch service provider Rocket Factory Augsburg had a massive win by successfully conducting a 280-second hot fire test of its upper stage at the Esrange Space Center in Sweden. This means they have completed their Integrated System Test, or IST, campaign. A staged combustion helix engine was integrated into an upper stage tank and conducted multiple hot fire tests. Confidence was high, so the final ignition culminated in a full duration burn. In doing so, it meant this was the first private European company to have successfully hot-fired a stage with a staged combustion engine for its entire duration. This milestone also qualifies the Helix engine for both first and second stage flight, showing exceptional performance and endurance during the testing campaign. The upper stage also completed the full 310-second auto sequence without any issues. Testing has confirmed fueling processes, sensors, propulsion, fuel management, and pressurization, with data assisting with future stage and engine development. Quite impressive. The next major milestone will be a hot fire test of the first stage, edging ever closer to their first launch. Rocket Factory Augsburg aims to offer highly competitive launch services capable of delivering payloads of up to 1,300 kilograms into low Earth orbit and beyond on a weekly cadence. Just a quick update for you now on the United Launch Alliance Flight Readiness firing, or static fire, at Cape Canaveral Space Launch Complex 41. Using the Certification 1 Centaur core stage and 2 BE-4 engines, it was go time on Wednesday, June 7th at 9:05 p.m. Eastern Time. This is as close as you can get to launching a rocket without actually doing so, meaning all the elements needed to fire up the engine came together perfectly for a 6-second burn. With this milestone now ticked, it's all eyes on when will this new vehicle launch. That's the multi-million-dollar question right now, and it all depends on whether any changes to the launch vehicle are needed and the primary payload, the Peregrine lunar lander, being ready to go. More to come on all this in the months ahead, that's for sure. It's all about energy. A strong statement. Energy is the capability of doing something, doing anything. Whatever we do needs energy. As you're watching this video, your laptop, your computer, or your mobile, it consumes energy. The network infrastructure and the servers too. When we travel, it consumes energy. When we eat, the production of food, transporting it to the shop, keeping the food cool in transit, and perhaps cooking, baking, it all requires energy, and a lot of it. The driving force behind our civilization is energy. Where does this energy come from? The answer to that question has changed many times during the 1,000 years of human history. Humans began with horses, then moved on to steam machines fed by coal. Then came oil and gas, the twin kings of fossil fuels. And lastly, nuclear energy pops up right at the end. The latest promise is renewable energy production. Burning fossil fuels produces the emission of long-buried carbon as CO2 into the atmosphere, and it has a high price, global warming with all its negative effects. So, the master plan is to avoid the usage of fossil fuel energy sources. What can we replace those with? Renewables and nuclear energy. Problem solved. We can go home and proceed our daily routine, right? Unfortunately, it's not quite that easy. Building nuclear power plants is a long process and is unpopular with the public and the politicians in many countries. Solar and wind power supplemented by good old hydropower could potentially solve our need for energy. But what's the catch? On our lovely planet Earth, solar and wind availability is dependent on the weather. It changes with the day and night, and it changes with the seasons as well. There are ways to get around this problem. Overscale the power plants, build more solar panels and more wind turbines, and then store this excess energy in a large battery to fill the gap of low production periods due to the adverse weather or unfavorable conditions. We'd also need to build a huge energy distribution network to smooth the changes in production to marry energy supplies with energy demand. All these possible actions have their own challenges and have a price on the environment and on our planet too. Scaling up terrestrial renewable energy production is also not easy and definitely has its limits. There is another way, which was imagined and written by our beloved sci-fi writer and scientist Isaac Asimov already way back in 1941. Why do we bother with the hurdles of solar energy on the surface of the planet when the steady flow of sunlight is available over the atmosphere almost 24/7 higher orbits in space? It is 100% predictable it has more energy, and this technology offers practically limitless growth in the future. Space-based solar power, or SBSP for short, was considered decades ago as a valid alternative. Studies were written on the topics. All investigations came to the same conclusion of one big obstacle: the price. Sending the needed infrastructure to orbit was expensive. Current launch vehicle developments are promising a drop in price per ton to LEO with more magnitudes. The various upcoming new rockets, the Starship, the Terran R, and Neutron, offer even better capabilities for less money. So how does SBSP work? We start with some solar panels creating electricity the same way as a conventional photovoltaic, as it would do on a rooftop solar system. Then it is converted into either microwave or laser radiation, which aims for the receiving station down on the Earth, which converts the radiation back into electricity and feeds into the electric grid, just like a regular power station. Carefully selected microwave wavelengths are considered the better solution, as the clouds do not affect the energy beam. The lower energy density of the beams ensures that flying through the beam would not hurt any animals or travelers on an airplane. The receiving rectenna area has to be big to accommodate the width of the beam. The rectennas could be placed above crop fields, creating a dual-use area so as to not take any land resources in its construction. Caltech started a project a few years ago, and they managed to achieve an important milestone. The Space Solar Power Project built a test device, which was launched with the momentous Vigoride satellite on the Transporter 6 SpaceX mission in January. The Space Solar Power Demonstrator, or the SSPD-1 for short, consists of the following instruments: Microwave Array for Power Transfer Low Orbit Experiment, or MAPLE, Deployable On-Orbit Ultra-Light Composite Experiment, or DOLCE, and a collection of 32 different types of photovoltaic cells to enable an assessment of the types of cells that are the most effective in the punishing environments of space, or ALBA. MAPLE has an array of flexible, lightweight microwave power transmitters. It features two separate receiver arrays located about a foot away from the transmitter to receive energy. The individual transmitter elements are controlled like a phased array antenna, so the transmitted energy can be dynamically focused on the desired location. In short, they can aim the beam of energy without moving any parts. Caltech managed to successfully demonstrate sending energy with MAPLE in the harsh environment of space without any protection on it. DOLCE demonstrated how bigger structures could be unfolded from a tightly packed small volume. The ALBA experiment measured 32 different types of photovoltaic cells to study their production characteristics in space. SSPP's vision is to send a constellation of solar cell-like integrated lightweight foldable panels to space, where they can be unfurled and start to collect sunlight, convert it to microwaves, and send it to long distances wherever it may be needed. MAPLE also sent a tiny amount of energy down to the ground, On the roof of the Gordon and Betty Moore Laboratory of Engineering on Caltech's campus in Pasadena, this energy was detected, and furthermore, the measurements matched the predicted properties of the experiment. Sick! ESA also has their own program. Solaris plans to create commercial-scale space-based solar power plants within the next 2.5 years. They will conduct studies and research to assess implementation options, the commercial possibilities of this technology, and to map the possible contribution of SBSP to the net zero decarbonization of European energy production. In the other corner of the world, in Japan, the Nikkei Corporation plans to beam down energy from orbit down to Earth in 2025. The project was the first to transmit power via microwaves in space back in 1980. Then in 2009, they successfully demonstrated sending power to a mobile phone from an airship flying 30 meters above. They continued their development of transmitting wireless power horizontally in 2015, and then managed to do the same vertically in 2018. The upcoming experiment in 2025 will use small satellites to send energy to ground-based receiving stations from hundreds of kilometers away. Of course, China is also developing its solution in Chongqing University. The recently completed Tiangong space station will be a test platform for this technology too. They will test the assembly of a test solar power station with the help of the Tiangong robotic arm, and then deploy the test station, which will conduct experiments and gather data on its operations. Longer term, in phases 3 and 4, China is planning a demonstration of this technology by sending 10 megawatts of power from space in 2035, and scaling that up to 2 gigawatts in 2050. So with all the debate on global warming heating up, let's hope that it leads to some cooling down on our Earth. Blue Origin is poised to resume launches of its new Shepard suborbital vehicle, possibly even as soon as a few weeks away. You may remember back in September of 2022, there was an in-flight anomaly during an uncrewed flight. Blue Origin CEO Bob Smith recently stated they were ready to resume New Shepard launches once they had approval from the Federal Aviation Administration. The anomaly itself was in the vehicle's BE-3PM engine nozzle, and thanks to the excessive temperatures generated, it triggered the capsule's abort motor as seen here in the spectacular imagery captured at the time. Despite the incident, space tourism bookings are hotter than ever, according to Bob, with new clients signing up for a quick popover and above the Kármán line. Well, that's it for now. With a nice hand-picked selection of other amazing news to share with you, we look forward to bringing you the latest developments in space news next week and some fun along the way. Thanks for watching, and remember, onwards to the future. Hello! No, you've got a good point. I seen the car and I was about to say, but recently, as they continue to edge closer to an inaugural launch. Yeah. Plenty happening this week. Plenty. Is Fantastic 9? Really? It is very fantastic, but still, will arrive at the Spud Rock. Spud Rock caught me off guard, I'm not gonna lie.